Hello friends, welcome to our channel. In this video, we are going to look at problem 2017, Great Game. In this video, we are going to explain how to use partial sums, including prefix sum and suffix sum, to address this problem. So basically here, we are given a 2x(n) grid, and a robot can walk through from the top left corner to the bottom right corner, and then we have another robot. It can do the same thing, but after the first robot pass will be making zeros of all the values there. So here, if you look at example 1, so you can actually analyze this problem first. So I would say we will not go through all the statement of the problem to save some time. So basically, the crux of this problem is that due to the assumption, the robot can only go right or down. So once the robot goes to the second row, it can only move to the right. So the main point or the crux of the problem is where the first robot goes down, right? Then, for example, in example 1, if the first robot goes down at the position 0, so it will collect the point 2, 1, 5, 1, right? So then so let me do this. So goes down at index 0. So the first robot will make the grid to be 0, 5, or 4, and 0, 0, 0. And then the second robot can only collect these numbers because all those are zeros. So if it cannot go down, if they go down, you are going to get zeros. So the second robot, so the first robot goes down at index 0. Then the second robot can collect. So either it's the left of this one, it's 0. So I'm going to write like this. So this part, right? This is none. And if we have some imagined, so we have some left side, so it's going to be 0. Let me first write like this. So this is none. So if the first robot goes down at index 1, so and index 1, so it will make the grid for second robot will be 0, 0, 4, and then this 1 does not change, so this changes to be 0 and 0, right? So the second robot can collect. So let me copy this one. So it either can go like this, so they can collect this 4, right? Or they can go down from index 0 to collect this 1. So it can collect the prefix sum, that is 1 for the second row, and the suffix sum after this one. So it's going to be 4, right? So because it goes to add 1, so it's going to be 4. So this will be 4. And then if the first robot goes down at index 2, so it's going to make the grid to be 0, 0, 4, and 1, 5, and so let's see. It's going to this one. It's going to be 0, 0, 0, and 0, right? So in this case, the second robot can collect. So that is 6. So the prefix sum, and the suffix sum for this one, because after index 2, nothing, so we get 0. So this is 6. So overall, so 9, 4, and 6, the minimum of 9, 4, and 6, that is 4. That's what we want to return. So that's also the main point. So as long as we can compute the suffix sum for the first row and the prefix sum for the second row, then we compare the larger, and then we overall get the minimum. So that's the problem logic. Let me implement this, right? So this implementation will be very straightforward. So here I change the function signature here to be a, just for saving some typing. So first I'm going to get the length of this the number of columns. That's the n in the in the problem because we know A has 2 rows, right? So then first I'm going to set the result to be float infinity, because overall we need to take the minimum. Let's first get a float positive infinity, right? And then so in order to compute the suffix sum, first let me do this suffix sum. So we can first sum the first row, and then the prefix sum is going to be 0 at the very beginning, right? So now we just iterate from for I in range n. So this I is interpreted as where to go down for the first robot, right? So if I go down, the robot go down from from the first index, and then so the second robot can collect a 5, 4, and 0, right? So let me do this. The suffix sum will be decremented by, so here let's if I is greater than 0, right? If I is 0, so we don't make any change, right? So the suffix is going to be like this. Suffix, we can always do this. So let me write suffix sum decremented by a naught and this index, right? So if I is greater than 0, then the prefix sum is incremented by a1, so I minus 1, right? So if you go down from the first index, so then the prefix sum will be this 1, right? So then the robot 2 score, or the points he can collect, is actually the max of the suffix sum and prefix sum, right? So for the result, we want to have the minimum of the original result state and the robot 2, right? So this is what we want to return. So that's the problem logic. So here actually I'm using O1 space because I just do a running variables prefix sum and suffix sum. You can also use ON to get this 2 pieces of information at each position by using 2 length and list. Before we make any comments, let's first do a test. Yeah, it passes all the cases, all the test cases. Now let's look at the generic case. Yeah, it passes all the cases. So here, let me mention that there are actually quite a large number of problems in leetcode which you can address using partial sums. So either prefix sum or suffix sum, or sometimes both. So with that said, actually, I would suggest you to look at this problem. Minimum penalty for shop. So that's actually a very similar problem you can use in prefix sum and suffix sum to address. So with that said, I guess that's about it for the current video. Thank you for watching.